Lab 6, Lecture on Mirrors. Once again, we will be using the Ray Optics Simulator to do this online lab on mirrors. Mirrors and lenses have the exact same equations that describe the image locations and characteristics. The mirror equation is a relationship between the focal length f, the object distance s, and the image distance s prime with this equation. So if you calculate the image location to be positive, then that's a real image, which means that the image must be on the same side as the object. On the other hand, if the image distance is negative, then that's a virtual image. That image is opposite to the object. The second equation is the magnification equation. There's the sign part, and then there's the magnitude. The magnification is equal to minus s prime over s. So if I have a minus sign, then that means that the image is inverted and real. If I have a plus sign, the image is erect and virtual. When I look at the magnitude of the magnification, if that is numerically less than 1, equal to 1, or greater than 1, then the image respectively is going to be smaller, the same, or larger in size. The big difference between lenses and mirrors is that light is reflected instead of refracted, and this means the sign convention has to change. So when I set up a converging mirror, the way this is bent, that indicates that. And we know that converging mirrors have a positive focal point, whereas diverging mirrors are bent the opposite direction, and we know that their focal length must be negative. So if I look at the focal point, that defines what's positive and negative. For rays coming to the left, the mirror focuses the light on the left side. So this focal point being on the same side as the object, that's what we call the positive side. So if the rays start from the left and then hit the mirror, when they reflect, they diverge away. But if you now extend the rays backwards, these backward rays then cross. They cross behind the mirror, and this region is then called the negative region. When drawing ray number 1, we always focus on the focal point on the left side of the mirror. For converging mirrors, when we're drawing ray diagram for diverging mirrors, ray number 1 has to go through the negative focal point. Now let's go set up the Ray Optics Simulator. Setting up the Ray Optics Simulator, always choose a horizontal line or ruler that goes all the way across the screen and center it on one of the grid marks, so that way you know that it's plane. And then always have a vertical ruler and use the grid, so that way you can actually set up, things that are lined up with the grid system. So when you look at the mirror, part 1 here is you're going to get a segment of the mirror. And once again, you want to choose it nice and long, and you want to make sure that you focus it you place it in the middle of the screen. So for part 1, I have a segment or plane mirror. If I come in here and I select a point source, then I could talk about its location of the object versus the location of the image, and then go through part 1 and actually answer those questions. Part 2, you need a concave or converging mirror, so that means I got to get rid of the plane mirror, and I got to come in here and I got to look for a mirror that's going to be, curved here. So now, according to this here, I believe this is a diverging mirror, so you're going to have to go in here. Nope, that's a converging mirror. So now I could come in here and I can choose the beam, or I could come in and choose the point and then look at the images for each of these situations. So then do part 2 using those 2 sources of light. For part 1, plane mirrors, select on the mirrors tab to get the segment, and this is the same as the plane mirror. Then use a point source as a light source to answer the questions. Part 2, focal point of a converging mirror. Select on the mirrors tab to get the ideal curved mirror. and then you have to set the focal length to get a converging mirror. You should use the same focal length in part 2 as you use in part 3. Then use the beam and the point source to answer the questions. To get the percent difference between these, it's the focal length of the beam minus the focal length of the source divided by the focal length of the beam. So we don't really care about the sign so much, so it's the magnitude of that. Part 3, image characteristics of a converging mirror. There are two parts to this piece here. One is a conceptual understanding where there's no calculations. The only thing that you have here is a ray diagram to guide you, which means you need to set up ray 1 and ray 2. And once you complete this, then go to the simulator and create ray 1 and ray 2 to actually see if they match up with your diagram. Conceptual understanding using ray diagrams. So what I have here is I set up my converging mirror where I identified F and 2F. So whatever focal length you used in part 2, that's what I want you to set up in F and 2F here. Now, when you look over here to the right, I'm not looking for numerical values for S. So that means if I start with an object of 2F, then that means here I'm going to set up over here, I'm going to be outside of 2F. So then I look at this location and then I draw a ray diagram for this. And then I move my object to where? My 2F spot. And then I go in between. And then I go inside the focal point. That's what I mean by these. So when I answer the locations of S prime, I don't want numerical values. I want it, is it inside of F? Is it between 2F and F? Is it outside of 2F? Is it behind the mirror? Those are the things that I want you to be writing in on this column right here. And then from your ray diagram, define whether it's real or virtual, inverted or erect, and tell me the magnitude. What do I mean by the magnitude? Smaller, same size, or larger. But remember, you need to draw the ray diagrams first. Once you do that, then we got to go back to the ray simulator. Now use the ray optics simulator to visually see the ray diagrams. So in the ray simulator, use blockers. So if I have a 100 centimeter length focal length, I could come in with my blocker and I could put a blocker right here. And this guy's going to be at 100. And then this guy's going to be at 200. You got to be careful because it's going to block the rays because it's a screen. So maybe set it up here so that it's away from your sources here. So then to pick one ray, remember, you go to your object height and then you put it in. And then line that guy up. So this is clearly ray 1, so I'm going to let you go in and do ray 2. So once again, I use blockers to identify my F, 2F, and the height of my object. Now compare this ray diagram here with the one that you drew with paper. So this next piece is on the mathematical understanding, mirror and magnification equations. Using the object details, that is the location and height, from the previous simulation when you were doing the conceptual understanding, move the object to the following locations and predict the image location and the height using the mirror and magnification equations. That means from the focal length that you had for the mirror, right here, choose 1.5 that focal length and choose 2.5 of that focal length, and then predict using the mirror equation here. Once you have that prediction, then go and set that thing up in the simulator and then take the percent difference between these two here. Now, for the height of this object, you need the original height. So the predicted height, you got to get this from the magnification equation. And when you get that magnification equation, note that the image height has to be the absolute magnitude of the object height. That's how you would calculate this, and then get a percent difference between the two. Then of course answer the question, how'd you do? If the percent small is, a small value, then you feel pretty good about it. If it's large, then you probably did something wrong. Go back and fix it. Part 4, diverging mirrors. To get a diverging mirror for this part, just change the focal length value that you have in the simulator already to a negative value. Then you're ready to go. So that means you got that focal length, you got 2f, and what you want to do here is that you just want to repeat this in the conceptual part from piece 3, but now for a diverging lens. So that means go draw the ray diagrams first for these locations. Once you have it for those locations, then go to the simulator and compare the two, what you did on paper versus what the simulator is. And then as usual, go in and ask the question, is it real or virtual? Is it erect or inverted? And what is the magnification? Smaller, same size, or larger? Have fun with the lab and let us know if you have any questions. Bye.